Hi, today we're going to be running through how to use the software Dove, made by Effigus Software. Dove is a deceptively simple application that connects with your ETABS models to speed up the reinforcement design process for columns, walls, and spandrels. Anyone who has used our other software product, Triply, will be familiar with the interface and some of the core concepts we're going to run through today. All right, let's get started. I've opened the Dove main window, which displays when we first open the program. Now, as Dove imports all the geometries and loading from ETABS, that's the first thing we need to do. So I'm going to head up here and click New from ETABS. When I do that, I'll be presented with this dialog to help us through the process of importing ETABS. If your ETABS API is set up correctly on your computer, you shouldn't have to change any of these options. However, sometimes the ETABS API can be slightly finicky, so you may need to manually set the ETABS executable path and or the DLL path in order to have it function properly. We can also select the method we want to use to connect ETABS. I'm going to leave it on .NET Core, which will give us the fastest results. If I hadn't yet opened the model I wanted, I could click the Browse button down here in order to select the .edb file that Dove will automatically launch in ETABS before importing. In this case, however, all I need to do is double-click my ETABS instance from the list here, and Dove will automatically connect and import our model. Now, the import can take up to a minute or so, depending on the size of your ETABS model, so I've skipped over that process here. Now you can see that my model has been imported, and I have my column, wall, and spandrel elements imported, as well as the slab outlines at each level. By clicking around on this table on the left here, I can change the currently selected level. It's also worth noting that we can select multiple levels by clicking and dragging, or by holding Control and clicking on multiple levels, the most recently selected level being the one that gets displayed. You can see down the bottom here on the status bar that the currently displayed level, as well as any other currently selected levels, are displayed in brackets. I'll run through what we can do with this feature a little bit later. Now, the first thing we should do is select which load combinations we want to use for design. If I click on the load combinations next to the levels tab up here, you can see we have a list of load combinations imported from ETABS. But by default, they'll all be selected for Ultimate Design and deselected for Fire Design. In this instance, I'm just going to go through and turn off some of the service load combinations and envelopes for the Ultimate Design and turn on the G plus Q combination for Fire Design. And to turn off bulk load combinations, I can select the load combinations, I can right click, and I can go uncheck selected, or just click on each one individually. So I'll leave that on the top 5 for the Ultimate Design and the G plus Q for the Fire Design. Now, before we get into the design process, I'd like to quickly touch on the concept of chains and how they're used both within Dove and Triply. Chains are a way of grouping elements across multiple levels. So, for instance, columns at the same plan location at each level should be assigned to the same chain to enable easy editing of multiple elements. The same is true for walls occupying roughly the same plan location at each level, and slightly less intuitively for spandrels, which may be sensibly grouped over multiple levels as well. Unlike in Triply, where the chain defines the load path of the structure, chains in Dove are purely used for ease of editing, which we'll touch on a little bit later. Chains are automatically assigned upon model import, but can be edited in the properties dialogs as required. By default, the chains aren't displayed, but if we go up to our eyeball in the top corner here, we can turn on chain name for columns, walls, and spandrels. And if I get out of that, you can see that the chain name, so C55, C56, C57, is now displayed for those elements. Now, if we want to, we can jump straight into viewing our design results for the default reinforcement. I'm going to go up here and click Check Columns at Selected Levels. I'll click on that. The column design for the columns at this level will be run. And we can go up to our eyeball up here and turn on utilizations for those columns. And once we do that, we can see that utilization for each of those columns is displayed, where obviously a utilization less than 1 means the column is compliant with the current reinforcement, and a value greater than 1 means that the column is overstressed and accordingly displayed in red. If I scroll down through the display combinations up here, you can also see that the utilization for the columns is calculated per load combination, and we can see that that changes as we scroll through. Now, if we want to see a bit more information on one of these columns, I can right-click on it and select Inspect Capacity, or alternatively, I can hold the Alt key and double-click on it. We're now presented with our design results dialog for this column, and we can see that we have capacity plots displayed for each of the two column axes, as well as the combined loading summary and design report. You can see for this particular column that it's working relatively hard, particularly in the M2 axis, where the axial utilization is sitting at 98%. The green and red icons represent the loads for each load combination. And if we hover over one of those, we're presented with the load combination name and the case at the station which those loads belong to. And obviously the red icons indicate that that load combination is failing, and the green icons indicate that that is a passing load combination. Over on the right here, you can see we have a text report, which gives us a summary of our design, outlines the details of that particular column being loaded, the design loading on that column, ultimate design summaries about the M3 and M2 axes, combined loading, a detailing summary, as well as fire design checks. If we go to the next tab, we also have a plot of the column as well, which lays out the number of bars as well as the arrangement of the fitments within that column. If we keep going, we have ultimate design summary tables, which provide a low case by low case breakdown of the results for that column. And then we have the same thing for the fire. At this point, we've yet to define any reinforcement for the column, so Dove is just providing the minimum reinforcement. We can click on Edit Column up here in order to edit this particular column. You can see that we're presented with this column's properties dialog. In this dialog, we're able to change the geometric, reinforcement, material, and design properties of the column. Obviously, the column geometry is imported from ETABS, but we're also able to change that if needed, and that will just give us a little warning until the new column dimensions are imported from ETABS that match the dimensions we've defined. Most of the editable properties in here should be fairly self-explanatory, but if not, there is a write-up on each property provided on the DELF help page. There are two key points I just want to touch on here. The first is reinforcement and the way we define that. We can either allow DELF to provide reinforcement based on a minimum percentage that we input here as a reinforcement ratio, or by unticking this use reinforcement ratio box, we can provide manual reinforcement to this column. An easy way to switch from one to the other is to use the bake button, where the reinforcement is defined automatically by a minimum reinforcement ratio and will be converted into manual user reinforcement. So if I switch back to reinforcement ratios, I can click this bake button and that'll automatically pre-populate that reinforcement with the minimum that we provided up here. The other point I'd like to touch on is the use of types within Dove. Each element has both type and instance parameters, with the type parameters being defined on the left side of the dialog and the instance parameters being defined on the right side here. All columns, walls, and spandrels within Dove can have types defined, which is essentially a way of grouping designs for particular elements. By default, all elements are defined as custom, meaning they have no type defined, and the type parameters can be edited directly within this dialog. If I click on Add Type up here, you can see that I'm now presented with the Type Editor dialog, which allows me to edit only the type parameters for this new column type, which will then be applied to all columns which are specified to be of this type. If I click OK and leave the default type settings, you can see that our new type is now assigned to this column. I'm no longer able to directly edit the type parameters for this column. If I need to edit any of these parameters, I can click on Edit Type up here to edit that column type. However, note, of course, that any changes to the type will be reflected in all other columns with the same type defined. Instance parameters are always defined individually for each column, so it can always be edited directly in the column properties dialog. Now, obviously, editing a single column at a time will not do, so we have a few options available to us to streamline this process. For instance, I can right-click on the column we just edited, and I can go Cascade Properties, Up Chain, Down Chain, or to selected levels. And that will copy the properties from this column to all columns in the same chain, either above or below this currently selected level. If I just want to copy the properties of this particular column to a few other columns, I can select it and click on the Format Painter button up here. And then I can simply click on other columns around this level, and they will automatically be provided with the same column properties as this column. I can also select multiple columns at once by dragging a box around them. So I can right click, select properties, and you can see in the top left corner up here, that we're editing 4 columns at once. So any changes that I make within this dialog will be applied to all selected columns. This multi-column editing functionality also applies across multiple levels. As I mentioned earlier, I can select multiple levels at once. And if I do that and then select some columns to edit by dragging around them, right-clicking, going properties, you can see, as before in the top left corner here, we're now editing 35 columns at 7 levels. So all of the columns in all of the select chains here are now being edited within this dialog. Just a quick note that Dove assigns columns to the level at the head of the column. So if I'm editing a column at level 3, that refers to the column sitting between the level 2 and 3 slabs. In this case, I've used columns as an example, but the same functionality applies identically to both walls and spandrels. Let's now design one of our spandrels. If I Alt double click this spandrel, we're presented with the design results. Again, just using the default minimum reinforcement. And we're presented with plots and reports similar to the column design results dialog we saw earlier. With spandrels, however, this second plot displays our shear utilization with the bending moment on the horizontal x-axis and the shear force on the vertical y-axis. The 3 plot lines represent the capacity curves at 0, minimum, and maximum axial loads for the spandrel under consideration. Whereas spandrel in compression will have an increased shear and bending capacity, and a spandrel in tension will have a reduced capacity. Each of these plot points obviously represent a load combination, and as I said before, if I hover over one of those points, I can see exactly which load combination it is, as well as the design loads associated with that combination. Much like with columns and wall designs, we are provided with a text report, a section plot of our spandrel, and the tabular report outlining the design results for each load combination. Now, if I want to change the design of this spandrel and see the results instantly, we can click Edit Spandrel up here. And we can see that the spandrel properties dialog for this spandrel appears. In this case, I'm going to bake the minimum reinforcement and then change to 2 layers of N24s. And maybe just decrease the ligature spacing a bit down to 300. And then if I click OK, you can see that these plots and the report have been instantly updated with those changes that we've just made. I'll now briefly touch on wall design in Dove, though the fundamentals are exactly the same as what we've just seen for column and spandrels. If I double click on one of these walls, I'm presented with the wall properties dialog for that wall. The properties are relatively self-explanatory, however, further guidance is available in the help documentation if needed. By default, if using AS3600 design, Dove will attempt to design walls using the simplified methods outlined in section 11 of that code. And only if that method is not valid for some reason, i.e. there is tension in the wall or you specify a higher ductility, will it be designed as a column using section 10. If we want to force Dove to design the wall as a column, we can toggle on that option here, this always design as a wall option. Dove will always detail walls in accordance with section 11 of the code, and it's also possible to have Dove design and detail columns as walls if required. I can now Alt double click on that wall to bring up the results dialog. You can see that we're presented with a plot and a text report similar to what we saw for the columns and the spandrels. However, this plot has been generated using the simplified methods of section 11 of the code, with the green data points down here representing the loads applied to that column. The text report, as for the columns, presents a design summary, details, the ULS summary, as well as a summary of the file design. And we can get a section plot, ULS, and file results for these walls as well. Now imagine we've gone through and we've designed all of our elements, but it turns out one of the earthquake load cases in the ETABS model was set up incorrectly, and now all of the loads have changed, and we need to recheck all of our lateral elements. Dove makes this easy by providing an update from ETABS functionality. If I click on the update from ETABS button over here, we're presented with a dialog where I can select the scope of the update process. In this case, only my loads have changed, so I'm going to uncheck everything other than update loads. But for instance, if I had added some extra columns in the ETABS model and I wanted to design these, I could also import these using this method. I'm now presented with our standard ETABS import dialog, and I can just select the relevant ETABS instance to import from in the same way that we did when we set up our Dove model initially. Now let's take a quick look at the global settings, and I'll point out a few key parameters to be aware of. So if we go up to File, Settings, we're presented with the Settings dialog. Most of these are fairly self-explanatory, but if we head over to the Design tab, then we see there are a couple of settings to be aware of. Notably, the user should ensure that the ductility and performance factors are set appropriately for the building being designed. These are used primarily for the design of walls, particularly in respect to the ductility detailing and shear amplification, which Dove performs automatically for walls with ductilities greater than 1. The other settings to be aware of are on the Wall Design tab and relate to the assumptions Dove makes in regards to the averaging of in-plane stresses when designing walls using the simplified wall method. Dove will take the minimum of the defined wall stress averaging distance and the ratio when determining what width of wall to average over the wall ends. In most cases, the default values of the minimum of 1 meter and 20% of the length of the wall should be appropriate. However, engineers shall make their own assessment of this. Finally, once we've completed our designs, we can export our design to a couple of different formats. If we click on Export up the top here, we can see that we're able to export spreadsheet summaries of our column, wall, and spandrel designs. We can also export designs for each of our elements. There's a few different options here. Most simply, we can right-click on any element, for instance, this column, and select Design Report, and click Export Report. If we do that, we're presented with a prompt to pick a save location for our exported PDF report. Alternatively, we can just click Include in Batch Export to mark the element to be included in a batch report export. To run our batch report export, we can go back to the Export menu, and we can click on Design Reports. We'll now be presented with a diagram indicating which columns, in this instance, are marked to have the design reports exported. Any column with a tick in its box will be exported, and we can add to the batch exports by clicking on any of these columns boxes, as you can see. Now to export the reports, all we need to do is select our export directory up here and click Export Column Reports down the bottom here. The process works exactly the same for the walls and spandrels, as you can see. And that about wraps up this quick Dove run through. Obviously, there is a lot more functionality available that I've not run through today, but the design process that I've outlined here shows the fundamentals of the Dove software. We are actively developing Dove and are enthusiastic to take on feedback from our users, so please do get in touch with any suggestions on how Dove may be updated to better suit your particular design workflows. Thanks for watching.